Okay, let's take a look at this worksheet. We have a couple more examples here. Find the absolute extrema of the function on the closed interval. All right, so we do have a continuous function on a closed interval here, so we must have an absolute max and an absolute min. And again, so the way we're going to do it is we're going to find critical numbers, so that's going to start with the derivative, negative 2x plus 3. Okay, two questions. Derivative equal to 0, derivative undefined. All right, I need to know if there are values that fit this. So derivative equal to 0, so if I do negative 2x plus 3 equals 0, I'm going to get x is 3 halves. Derivative undefined, none. There aren't any places where negative 2x plus 3 is undefined. So I have the one critical number here of 2/3, and I have my endpoints. So again, I like to write the original function again just to make sure I'm plugging into the right place. So I'm going to do f of 0, f of 3 halves, and f of 3 because of my two endpoints and my critical number. Okay, at 0, I would get 0 plus 0 is 0. At 3 halves, I get negative 9/4 plus 3 times 3 halves is 9 halves. That gives me 9/4 if I add negative 9/4 and 18/4. All right, f of 3 would be negative 9 plus 9 is 0. All right, so we do have our absolute max of 9/4 occurring at 3 halves. And then we have tie, so we have an absolute min of 0, which occurs both at 0 and at 3. Again, you don't really have to say where they're occurring. The real absolute max and absolute min are the values 0 and 9/4, but I just like to also indicate where they are. Okay, how about t squared over t squared plus 3 on negative 1, 2? Again, this function is continuous on that interval, so we better have them. So g prime of t, quotient rule, 2t times t squared plus 3 minus t squared times 2t all over t squared plus 3 squared. All right, that's 2t cubed plus 6t minus minus 2t cubed over t squared plus 3 squared. All right, that gives me 6t over t squared plus 3 squared. All right, so again, there's my derivative. I'd be asking, when is g prime of t equal to 0? When is g prime of t undefined, and specifically when the function is defined? When is g prime of t equal to 0? Look at the numerator. That would be t equals to 0. Undefined, none, because look at the denominator here now. T squared plus 3 is never going to be 0. So that's the only way we could get that rational function to be 0. So I have my function g of t equals t squared over t squared plus 3. And I'm going to do this at negative 1, at 0, and at 2, my endpoints and my critical number. All right, negative 1, I'll get 1 over 1 plus 3. I'll get a fourth. 0, I'll get 0 over 3. I'll get 0. And at 2, I'll get 4 over for 4 plus 3, I will get 4/7. All right, so there's my absolute max. Whoops, I realize I'm off the screen down there. Sorry about that. My absolute max is g of 2 as 4/7, and my absolute min is g of 0 equals 0. There you go.